Alright, so just a quick tutorial on graphing logarithms again. So if you were graphing something like just log base 2 of x, it's not too bad to pick out x values in base 2 that would give you nice integer answers. However, when there's a horizontal shift like x minus 3, or if they put 3x minus 1 in here, it becomes a lot tougher to graph your logarithm or find nice values of x. So here's a way that makes graphing these by hand a lot easier. We're actually going to change it to exponential form at some point. So these are the steps we're going to follow, okay, to do that. So we're going to start by isolating our logarithm. So I mean, in this case, we're going to have to subtract 1 from both sides. We'll do that. Subtract 1. Y minus 1 equals log base 2 of x minus 3. Okay, so that's step 1. Step 2 is we're going to write this in exponential form. And remember that the base of my logarithm is the base of my exponent. So it's 2. And then my exponent is what my logarithm is equal to. So y minus 1 is my exponent. Equals the value or expression inside my logarithm, x minus 3. Okay, so we've written it in exponential form. Next, we're going to isolate x. So we're going to add 3 over to this side. So we have 2 to the y minus 1 power plus 3 is equal to x. Okay, and this is what we're going to use to generate the values in our t-chart. Okay, so we're going to do this a little backwards though. We're going to pick values of y and solve for x, rather than pick values of x and solve for y. So we have y written as a function of x right now. And the one you want to start with kind of in the middle of your t-chart, that's going to give us the best points or the best picture of this logarithm, is to start with the value of y that makes your exponent 0. So in this case, positive 1 is a good value to start with in the middle, because 1 minus 1 is 0. So when I plug in 1, we have 1 minus 1 is 0. 2 to the 0 power is 1, and 1 plus 3 is 4. Okay, so plugging that in, we get 2 to the 0 power, which is 1, and plus 3 gives us 4. Oops. Okay. Next up, let's try another point. Let's try a few more y values around this, maybe 2 and 3, 0 and negative 1. Okay, probably plenty of points for us. So let's start with the next positive one here. 2. 2 minus 1 is 1. So I get 2 to the first plus 3, which is just 2 plus 3, or 5. Okay, so 5, 2 will be on my graph. Let's plug in 3 for y. 3 minus 1 is 2. 2 squared plus 3 is 4 plus 3, or 7. Okay, so 7, 3 is on my graph. Let's go the other direction. If I plug in 0, 0 minus 1 is negative 1. So I get 2 to the negative first plus 3. Oops, I'm pressing the button there. 2 to the negative first is 1/2 plus 3, which is 3.5. So we can just leave it as the mixed fraction to estimate that graph, or 3.5. If I plug in negative 1 minus 1 more is negative 2. So we get 2 to the negative second, which ends up being 1 over 2 to the second power, or 4, plus 3. So we get 3.25. Okay, so if we think back just to where my asymptote is, and we do have a vertical asymptote here, remember that the inside of logarithms have to stay positive. So you could mathematically or just algebraically calculate your domain by saying x minus 3 has to stay greater than 0. That has to be positive, or my logarithm's undefined. And if you add 3 over, we find our domain. X has to be greater than 3. And in fact, this is the value where my vertical asymptote is. So I have a vertical asymptote. It's not easy drawn on this pad here. At positive 3. Well, you get the idea. And then let's plot a few of our points. We got 4, 1, 5, 2, 7, 3. Okay, then we have 3.5 for x is at 0. 3.25 is at -1. And we're going to just start getting infinitely close to +3 in this direction, and then curve off upwards and outwards, continuing up and to the right forever, continuing down forever, and getting infinitely close to that vertical asymptote at x equals 3.